So I think that it's very clear for all of us that actually bandwidth is actually growing. I think that we're all stuck in the, houses basically, and what we can actually see is that we need more and more actually bandwidth, more IP video for our conference calls, more of mobile for actually connecting it, more of data center, I would say capacity for our kids movies and for like basically video games as well as for data analytics, and in the future for the VR and actually AR. If we take a look into the total, I would say volume, I think that it's very clear that data center capacity was the basic, I would say, kind of revolution, while the VR AR is going basically to be the next one. The outcome of that is that we see that Ethernet speed are actually growing, and the next few kind of years we will start to see the 400 gig as well as the 800 gig and 1.6 terabit per second Ethernet speeds, so that we can actually suffice with this huge bandwidth, I would say, demand. So what is the biggest, I would say, challenge? I think that the biggest challenge here, and I think it's clear to this audience, is that we need to scale all of the transceiver technology. The transceivers themselves are actually turning into being a multi-billion, I would say, market. And while this is actually coming, it comes with great new challenges. And the basic kind of question is, how can we take all of this cost down? So if you take a look into what is actually doing all of the cost here, then I think that it's becoming very clear that while the silicon chips are actually have some kind of a gap of how low cost you can actually take it, and while testing is being improved, as we will hear about this in the conference here, I think that it's becoming very clear that assembly, lasers, connectors, and PCB are being the critical mass of the cost. And actually, transceiver costs are highly dependent on assembly cost. And while most of the transceivers today are highly built on low-wage production and manual production, the biggest, I would say, challenge is how do you take it into automation so that you can actually reach the, I would say, holy grail target of $1 per gigabit per second and even lower. I think that it's becoming more and more of a challenge if we take a look into the net market. We see this becoming actually scale, and while people no longer only talking about optics as a transceiver, but it's becoming more and more of a challenge into the core package. How much can we actually scale the bandwidth if we will actually need onboard optics? The major challenge, like how to go into 800G modules, becoming even a challenge to the switch itself, creating a huge challenge about how much bandwidth can you actually take out of a switch. So what is the wish list? What we would really like to actually happen? I think that this is how we actually started basically the project. I think that the key challenges is how can we take a lot from the VLSI industry into this market? How can we take integration density, high temperature operation, and high channel count into the mass production? For that, we are actually using the 300 millimeters silicon photonics platform, but we're taking a look into the challenge of actual assembly. We took the TSV capability of the silicon photonics for easier assembly, and basically we take the high TRL laser assembly as well as simple and in plane, as well as dense fan out for the optical coupling, so that we would be able to actually control the full supply chain of actually low cost assembly. So if we will turn from a little bit from the buzzwords into the actual, I would say, technologies and the actual partners, what we see here is that we're counting a lot of the Reality new and impressive 50 gigabaud silicon photonics platform using the Almea laser array for easier assembly, as well as for dust photonics and team photonics optical, I would say, solutions, while Ficotech actually provide full automation that, as we said, is very much, I would say, critical. Our challenge in this will be to actually take all of those building blocks, I would say, together. And by doing so, what we will actually try is to mix and match all of those basically together for several prototypes. So what are, I would say, the prototypes? And this is highly related to the challenges that we have showed in the beginning. So the prototype, I will say, the first one is the simplest one, yet it will actually allow us to show a lot of the technologies. So the first one is the 400 gig DR4 transceiver, which would be one of the most common, I would say, transceiver in future data centers and cloud. It would actually have a lot of the electrical 50 gig interfaces while actually taking 4 times 100 gig optical, lanes. It will be no WDM solution, so highly parallel one. Yet it will allow us to actually check all of the assembly flow and basically all of the connection that we have talked about, I would say, before. Those basic concepts are now in the design and actually continue. So if we take a look into the EVP platform, layout that you can see in the left, we are actually in the plan, or like in the making of basically the floor plan. We have all of the layout. We have a DSP platform for commercially available, I would say, drivers, because that's not the main point, as we've shown before. And the silicon photonics chips are in the foundry, and assembly will start in Q1 2021. The second prototyping, like which we're a little bit more brave, we will start to play with 8 times 100 gigabit per second PAM4 optical lanes while actually combining WDM optics. We will actually take this as the first kind of challenge to check if we can still save the same low-cost solution, but in an assembly platform and in a WDM basically solution. We see more and more of the data centers and the cloud actually providers choosing the single mode fiber infrastructure of a WDM. And the last and most brave, I would say, is prototype 3, in like which will go into the first challenge of 1.6 terabit per second, transceiver. In this part, we will take 16 lanes. We will check the LAN WDM option again with 2 times 8 lambda grid, and we'll focus on the scalability. How much can we control the assembly platform for advanced optical IOs, while actually doing this in an EVP that will be later fit into a co-package module. So allow me to basically conclude. I think it's becoming really clear that silicon photonics is increasingly relevant for low-cost, short-reach, low-cost transceiver for the single mode fiber infrastructure. I think it's becoming very clear that we need to dramatically reduce the cost of assembly and packaging so that it would meet these targets. MASSTART is actually one of those projects that is actually developing the end-to-end, I would say, solution, not taking only one challenge, but the entire challenge of assembly and assembly cost. And we'll take the different demonstrators that I've talked about just to show the basic different concepts. All of the assembly saving the same low cost for a WDM system while showing that we can actually scale this in an EVB toward a co-package module. I would like to acknowledge basically the MASSTART project and thank you once again for allowing me to give this, I'll say, talk here. This is a funded project by the H2020, and of course, besides talking, there are people that actually have basically to do the work, and in my group allow me to further acknowledge both Anna and basically Paraskevas for their, I would say, tremendous work here.